Okay, the last part of our direct variation, we're going to have three real world problems here. A recipe calls for 4 cups of flour to make 8 cookies. Assuming the number of cookies varies directly with the amount of flour used, how many cookies can be made with 10 cups of flour? So, first things that I noticed is it says that cookies varies directly with flour. So, one of the things here, they didn't throw in the variables x and y, but again, it's always y before the x. So, cookies is going to be my y variable here. So this is my y. And the flour is going to be the x. So we're going to set up our k first. K is y divided by x. In this problem, that k is what we need to figure out is what have they given us? They've given us that it calls for 4 cups of flour to make 8 cookies. So cookies, again, that was y. So the 8 is y, my 4 is x. So we're going to go 8 divided by 4, which gives us 2. So k is 2. Okay, the next step is to then figure out how many cookies can be made with 10 cups of flour. So here we have cookies. That's my y. And flour is the 10. So that number represents my x in this case. So we're going to set y is equal to k times x. We're looking for y. Y is equal to 2 times 10. So y is equal to 20. So in other words, 10 cups of flour equals 20 cookies. Okay, the second problem says the weight of an object on Earth is directly proportional to its weight on the moon. If an object weighs 60 pounds on Earth and 10 pounds on the moon, what would the object weigh on the moon if it weighs 45 pounds on Earth? So, the weight of an object on Earth is directly proportional to. That's a direct variation question then. So, I'm going to start off with finding k. K is y divided by x. Well, we have Earth is directly proportional to. So I'm going to call this my y to the moon. So Earth is directly proportional to the moon, which is x. So on Earth, if an object weighs 60 pounds on Earth, so this is my y, and 10 pounds on the moon, that's my x. So we're going to set k to be 60 over 10, which gives us 6. So k is 6. So the next part of it is, what would the object weigh on the moon? So this is the unknown that we're looking for. So this is my x. This part is if it weighs 45 pounds on Earth, which is my y. So we're going to have y is equal to kx. So we're going to have 45 equals 6x. If we divide by 6 on both sides, we're going to be left with x equals, oh, what was that? 7.5. So to interpret this, we're going to have 45 pounds on Earth is equal to 7.5 pounds on the moon. And problem number 3, to finish out the direct variation. A machine produces 150 parts in 5 hours at a constant rate. Assuming the number of parts produced is directly proportional to the time spent operating, how many parts would it produce in 8 hours? So going back, how do I set this up? I know it's going to be k is equal to y divided by x. My y is going to be parts. So this is my y, and it's directly proportional to the time that I spend operating it. So this is my x. So k is equal to, let's figure out, the y comes from the 150. My x is my 5 hours. So 150 divided by 5, which gives us a K value of 30. What that means is it's 30 parts for every hour. Okay, now, how many parts would it produce in 8 hours? So how many parts? There's my unknown. Parts again, that was Y. The 8 represents the time. So there's my X. So Y is equal to K times X. We know the X, we know the K. So Y is equal to 30 times 8. Y is equal to 240. And what that means is 8 hours operating the machine produces 240 parts.